Today I wanted to take a few minutes to talk to you about static routing. So why do we need to learn about static routing? Well, a router actually builds routing tables, and a router can learn about routes in order to build the routing tables based on static routing or dynamic routing. With dynamic routing, a router would share its knowledge of routes or how to get data from one place to the next. It shares its information with another router would share it with that router, and they learn and just kind of change dynamically. Okay, so if there's something that's going on a network, a route goes down, that would be dynamic. It would automatically adjust to whatever changes happen in the topology. Whereas with static routing, this is done manually. So as network administrator and being in charge of a network, you would go in and configure this manually. There's advantages and disadvantages of doing static routing. For example, the disadvantage would be that the larger your network gets, the harder this is actually going to be, the process, because you have to go in and manually enter each of the routes. Okay, so just think about static IP addresses. So if you have static IP addresses, every time you need to move a computer to a different network, you would have to go in and manually configure it. Whereas with dynamic assignment of IP addresses, that would just automatically happen. So same thing here with dynamic and static routing. So with dynamic routing, if a route goes down, dynamic routing takes over static routing. You're doing that. It's much harder the bigger your network is. It's a lot easier if you have dynamic routing for all that to take place. Okay, so when your topologies change, you have to go in and manually make all those changes yourself if you're doing the static routing. Now, so some advantages of static routing: security. Okay, so if you're doing dynamic routing, those routes are advertised over a network. Now, when they're advertised over a network in a routing protocol, if somebody were listening in on your network, they would also know about whatever's being advertised. So that does not occur when you have static routing. It does make it more secure. Also, the router does not use more CPU usage to calculate anything in static routing because you're doing that for the router. Whereas with dynamic routing, now with dynamic routing, the router is going to have to configure all that based on whatever's in the routing table and use a lot of other criteria, which we'll talk about a little bit later. But for static routing, let me use one screen here. I'm going to flip back and show you where this would be beneficial. So if I were looking at the scenario that's on my screen here, if I'm looking at R1, okay, R1 would know about devices directly connected to it. So if you were looking in a routing table and you were to do the show IP route command, see the routing table. Now we're looking at this routing table. These are the routes the router knows about. If the router doesn't know about a route, then it can't get anything to a different network. So automatically when you go in and configure R1, you would configure this IP address for the G00, you would configure it for G01, you would configure the S00. Okay, those would show up in your show IP route with a C. Okay, and then the L, so the C for the network number, so 10.0, and then you would have the L for the actual link, which is the .1. Same thing for this network and this one. You would go in and configure R2 same way. So you would have a C for the 10.110, 10.120, and then for this network showing the 226. When you do that, those devices can ping anything directly connected to them. So for R2, for example, if you go in and ping, you should be able to hit this PC, this one, here, and this one really because you're directly connected to it. But R2 has no knowledge of remote routes, so it would have no knowledge of the 10 network or the 11 network. Same thing with R1. R1 would know about this network, it would know about this one, and it would know about this network because it's attached to it. But it has no knowledge of remote routes, and that's where your static routing comes in. You would go in and configure it. And when you go in and configure it, there's several different ways that you can actually do that. So I'm going to show you a couple of these. One of the things too, when you're looking at static routes, is notice that it does make the routing table smaller because your router is not having to do as much work, not having as many entries. I'll show you a couple of those. You can do routing for stub networks, which are just accessed by a single route. So for example, out to the internet. That's the only place you're going to go. You just point everything off to the internet. If you don't know where to go, go here. Okay. So that's where your default route would come into play. And that's what a lot of people use, just to point things off to their service provider from their network. Okay. So I'm going to show you specifically some of these ways you can configure static routes. So a standard static route. A standard static route is the default one, and I'm going to go back to the beginning of the chapter with the scenario where I was showing you here, because to me I like this scenario. You can see it a little bit better. And I'm pulling up this Word document, and in this Word document I'm going to actually show you how you would configure this. Hopefully you can see all this on the screen. So with this scenario here, I mentioned that with R1 you can see directly connected, but you can't see remote networks. So if I were in R1, for example, okay, this is what I would configure. Okay. Now here's your syntax. So let me put that in there first. Here's your syntax when you're configuring a static route. So the syntax is IP route is your command, and then the destination network that you want to reach. Destination network. Okay. Then you would put its subnet mask. Okay. I will put all of these together with no space just so you can kind of see where that's supposed to be. So IP route, destination network, space, its subnet mask, another space, and then next hop or exit interface. And I'll talk more about that. So for R1, if I'm in R1, so I already know about the 10 network, the 11 network, and this 209 network in the middle because I'm attached to it. But I don't know how to get to the 10110 or the 10120, which are on the other side of R2. So this would be what I would type. IP route, my destination network, I want to go to 10110 space. What is it subnet mask? That's a /24. So this is where some of that CIDR notation is going to come into play, and the fact that you have to know what the equivalent subnet mask is. For example, a /24 is equivalent to 255.255.255.0. Okay, so IP route, destination network, its subnet mask, and the next hop. So if I'm R1 and I want to go over here, my next logical step would be have to go here to the 226. So 209.165.200.226. Also with R1, I also don't know about that 10120, so it's going to be the same thing. So IP route 10120, its mask is same thing, and then you're still going to have to go to the 226 in order to get there. So the way that I would say that you think about this is, where do I want to go? What is a subnet mask? And what's my next step in getting there? That's how you need to think about it. Okay. So that would be R1. R2, you're going to do the opposite. Okay. So with R2, you would look at it and say, well, I know how to get to the 10110, 10120, and then the one in the middle. So, but I don't know how to get, I'm going to do IP route, I don't know how to get to 192.168.10.0. What's its mask? 0. Now, how do I get there? What's my next step? The 225. So 209.165.200.225. And then you're going to do the same thing to get to the other route. IP route 192.168.11.0 with its mask. And it is 209.165.200.225. Okay. Now, if you were to go into each one of these routers, then you could, that route would have everything that it needs in order to get from one place to the next. Okay. So that is just a traditional static route. Okay. So then that is your first type, standard static route. A default static route. With a default static route, again, this is a scenario where I would say you would configure that for your ISP. And in this case, what you would do if this is the bordering router to your network and that is your internet service provider out there, then what you could say is, I want you, if you don't know where else to go here. Because when a router looks at a routing table, what it's going to try to do is match its destination, so where are you going, with each of the routes that are in the routing table, and it kind of goes through and looks at each of those networks. If it doesn't know where to send it though, the way a router works, it'll just drop the packet unless you have a default route in place. And the default route will say, if you don't know where else to go, go here, instead of just dropping the packet, because your data may not get to where it needs to be. But more than likely, if you have this pointed off to an ISP, the ISP can get it where it needs to go, so that's not dropping the packet. And you'll see that often listed as a gateway of last resort if you're looking at your routing table. All of these will be listed with an S, but your default static route will be a gateway of last resort. This is configured a little bit differently. So when you're configuring your static route, for example, you would use quad zeros, which sounds really weird. So let me go in and show you a new page. So if you're looking at that, it's trying to show me auto recovered things. So if you're looking at your static route, it would be IP route, okay, and then it's going to be zeros, what I call quad zeros. So instead of the destination network, it's quad 0, and the subnet mask will be quad 0. And then you would have still the next hop, okay, and then that would be how you would configure it each time. So in this scenario here, you would tell it, if you were configuring this on R1, you might point it off in this direction. So IP route, quad 0, and then next hop or the exit interface. Now, this scenario here for the summary static route, this is a little bit different. So a summary static route will summarize multiple routes into one single summary route. Why do you care, or why does the router care? Well, when a router is matching up things in the routing table, in this scenario they would have the 172.20.00, 21.00, 22.00, 23.00, or you could go in and manually summarize all of these into one route, and then the router only has to go through one match as opposed to 4. So you may not always get it down to one route. Even if you go from 4 routes to 2, that's better than one route. So you're probably wondering, like, how does this happen? Let me show you. I'm going to use the same one here. So you've got to think in terms of binary. Now, in this scenario here, we have the 172.20.0.0/16. You've got the 172.20.0/16. You have the 172.22.00/16, and then you have the 172.23.00/16. So all of these routes. Now, if you're looking at these in terms of binary, so you're going to have to think about that in terms of the pairings for these, how the bits line up. So if I were to look at this, and if you remember your binary, so drawing this out, all right, so you know 172, if you were to draw this out in binary, you see how that would be. They would all be the same. But you see the change here in the second octet? This is kind of what you want to look at. So what you would do is say, well, that would be this in, if you were looking at it in terms of binary. So just define 20. So it would be 16. 4, that would be 20. Okay, so there's that. And then if you were to look at, let's see, make that a little bit easier to see. Okay. If I were to look at the, I believe that was supposed to be 21. Sorry about that. So 0, 0, 0. We have a 1, 0, 1, 0, 1. Then we have 22. So with 22, we have 0, 0, 0, 1, 0, 1, 1, and 0. And then you have 23. So with the 23, you have 0, 0, 0, 1, 0, 1, 1, and 0. So if I were to look at these, again, my alignment is maybe not the best. When you summarize a route, you look at all the bits from left to right, and you say, okay, so if I were to have done the 172, they would all have been the same. So we know the first 8 bits would be the same. And then we go to the second octet, and we say, okay, this line is the same, this is the same, this is the same, this is the same, but starting right here, this is where it starts kind of changing. Okay. So really, well, actually it's the same there, 1, 0, 1. It's this one right here that's different. So if you look at these bits, so it would be the last 2. See, that's where you kind of draw the line there. They're really all the same all the way up to that. So we know the first 8 bits would be just alike. And then you have 9, 10, 11, 12, 13, and 14. Okay, so that's where it starts changing with the address. That's the /14. So that address of 172.0.0, that's where, okay, that's where we have the common thread. That is the summarized route. That would summarize all of these routes. You see we have the same thing here, 172.20.0.0, and that's the summary route that you would have when you add that in. So you would do that in your IP route command. Okay. The fourth type of static route is a floating static route. So a floating static route is used as a backup route. You see that over here. You see floating static route here, backup route here. They're the same thing. Here's how that works. So with a dynamic routing protocol, we use administrative distance. Okay, the administrative distance of a route is the trustworthiness of a route. The lower the administrative distance, the better, or the more trustworthy it is. If you're looking at a directly connected device, it would have an administrative distance of 0. If you're looking at a static route, that would automatically be configured with an administrative distance of 1. That's how it would be seen. You start getting in dynamic protocols, which are not quite as reliable, the numbers start getting higher. Okay, so you can look at RIP and it is at 120, or you can look at OSPF, okay, and that's at, I believe, at 110. Okay, so EIGRP is 90, so they're much higher. So here's how you would configure a floating static route. It would be a backup route to your dynamic route. So if the dynamic route goes down, then it can use a static route. Well, since static routes are typically a lower administrative distance, the router would choose the static route over the dynamic route. So in order to keep that from happening and make this actually a backup route as opposed to being chosen first, what you would do is configure a static route, but then you would add a new administrative distance. So for example, if you're using RIP and its administrative distance is by default 120, you would configure the static route to have an administrative distance of 121, which would be one number higher than the administrative distance of the routing protocol. And that would allow the router to go ahead and use its protocol. If that one fails, then it can use the backup route that's been statically configured by the network administrator. So those are your different types of static routes. So you have a traditional static route, you have a default static route, then you have a summary route, and then you have the floating static route. So I hope that helps you a little bit on this chapter with your static routes.